2020, paper 1, question 1. f of x is equal to x squared plus 5x plus p, where p is between minus 3 and 8 and p is an integer. Find the value of p for x plus 3 is a factor. We know that if x plus 3 is a factor, we know that x equal to minus 3 is a root. What can we do with roots? We can sub them into the function. When I sub root into the function, it must be equal to minus 3. So now I have an equation with only one variable I can solve. And we can solve for a value where p is equal to 6. Part 2, find the value of p for which f of x has roots which differ by 3. So I'll call one of these roots n, and seeing as they differ by 3, I'll call the other root n plus 3. From roots, I can now make factors. So my two factors are x minus n and x minus n minus 3. I can now multiply the two factors to make the equation, and when I multiply the two factors, I should end up with the equation x squared plus 5x plus p. Once I factorize out my x, I have x squared minus 3 minus 2nx plus n squared plus 3n on the left, and x squared plus 5x plus p on the right. My x squareds on the left equal my x squareds on the right, and my x's on the left should equal my x's on the right. My constants, that's things without x's, on the left should equal my constants on the right. Solving my x values, I get n is equal to minus 4. Subbing that into my equation for my constants, I finally get a value for p, which is 4. I could have also done this directly using just the roots, knowing that a quadratic is made by x squared minus the sum of the roots times x plus the product of the roots, and let that equal to x squared plus 5x plus p. Part 3. Find the two values of p for which the graph f of x will not cut the x-axis. If it does not cross the x-axis, then it cannot have real roots. Therefore, the roots must be imaginary. If the roots are imaginary, then the discriminant, b squared minus 4ac, must be less than 0. A is equal to 1, b is equal to 5, c is equal to p. If 5 minus 4p is less than 0, minus 4p is less than minus 25. Dividing across by a negative 4 now, remember to reverse the sign. So you get a value of p is greater than 6.25. Find the range of values for which x is equal to the absolute value of 2x plus 5 minus 1 is less than or equal to 0. Our absolute value signs here. Different ways we can solve this. We can square both sides. We can use that minus 1 on the other side, making it positive and negative, but also changing the inequality signs, or we can graph it. The easiest way here is probably just to square both sides, but first I'll bring the minus 1 over. Once the 1 is over, squaring both sides, we have 4x squared plus 20x plus 25 is less than or equal to 1. We have a quadratic inequality. The rule is everything on the left, make sure the x squared is positive. When the 1 comes over, it leaves me with 24 at the end. Now I can divide everything across by 4. I don't have to worry about the inequality sign because I'm dividing by a positive number. Now my quadratic is on the left-hand side. The x squared is positive. I have 0 on the right. So I'm ready to solve the quadratic itself. And then the final sign that I use is going to be the sign I use in my answer. So solve x squared plus 5x plus 6, either using back-to-back brackets or minus b formula. You get x equals minus 3 and minus 2. So for inequality answer, put down your x value. Put your inequality both sides. Small number on the left, larger number on the right.